Picture this for a second. Everything you can see right now, the coffee in your hand, the sky outside your window, every star you'll ever spot on a clear night, all of it exploding into existence from one single, impossibly hot, impossibly tiny point. Not destruction, creation. And that moment, it still echoes across the cosmos today. So how did our universe really begin? Was it actually born from one gigantic bang? And if it was, what did those first impossible seconds actually look like? The real answer isn't the Hollywood explosion you're picturing, and once you hear it, you'll never look at the night sky the same way again. Back in the last century, American astronomer George Gamow proposed something radical. He said the universe didn't always exist in the calm, spread-out form we see today. It started incredibly dense and hot, then began expanding and cooling, like the after effects of one massive explosion, but on a scale we can barely wrap our heads around. This Big Bang theory is still the biggest, most supported idea in modern cosmology, and according to it, the entire 20-plus billion-year story of the universe breaks down into three clear stages. Let's walk through them together, one by one. Stage 1 hits right after that initial moment. Temperatures shoot above 10 billion degrees Celsius. Density is off the charts. There are no atoms, no stars, no planets. Not even Earth, the Sun, or the Moon exist yet. The whole universe is nothing but a seething soup of the most basic particles: neutrons, protons, electrons, photons, neutrinos. This extreme phase lasts only seconds. Then the universe keeps swelling outward. As it does, it cools fast. When temperatures drop to around 1 billion degrees, we slide into stage 2. This is when the very first chemical elements start to take shape. Over the next few thousand years, the temperature keeps falling, eventually reaching about 1 million degrees. The early atomic nuclei lock into place. The cosmos is now filled with protons, electrons, and powerful radiation, but still no stars, no galaxies, just a glowing, energetic haze. Finally, as the temperature falls further to just a few thousand degrees, we enter stage 3, the longest chapter by far. This is the one we're living in right now. Radiation fades, gas clouds slowly gather into nebulae. Those nebulae birth the first stars, then whole galaxies, and the universe we recognize today slowly takes form, vast, colorful, and still changing. Here's the part that still gives astronomers chills. At first, almost nobody paid attention to Gamow's idea, but then the evidence started rolling in. When we look at galaxies far beyond our own Milky Way, their light is stretched toward the red end of the spectrum, the Doppler effect telling us they're racing away from us. The universe is still expanding. Even more mind-blowing, in the 1960s, scientists discovered a faint microwave glow coming from every direction in space, exactly 3 degrees above absolute zero. That's the cooled-down leftover heat from the Big Bang itself. We're literally bathing in the afterglow of creation, right now, everywhere we look. The explosion never really stopped. We're still inside it. So what does any of this mean for us here on Earth? The simple atoms that make up most of the ordinary matter around us, the hydrogen in the water you drink, the helium that once filled your childhood balloons, were forged in those first few minutes after the Big Bang. The heavier elements came later inside stars, but the foundation of everything was laid in that primordial fireball. We're not just living in the universe. Every atom in your body carries a direct line back to its very first moments. The story of the cosmos isn't some far-off tale. It's the story of us. The Big Bang Theory has passed every test we've thrown at it for more than 70 years, yet it still leaves the biggest questions unanswered. What existed before that first instant? What triggered the expansion? And what else is out there that we haven't seen yet? The more we look, the more the universe keeps surprising us. So the real question isn't just how it began, it's what we'll discover next.